Imagine a grand symphony orchestra. You've got dozens of musicians, right? Each a master of their instrument playing these really complex parts. But who brings it all together? Who makes sure every note, every tempo, every crescendo contributes to the final piece? It's the conductor, isn't it? The person with the big picture view and the minute by minute control, kind of guiding all that chaos into harmony.
That's a perfect analogy, actually. In the sprawling, intricate world of construction, that master conductor, that's the general contractor.
The GC.
Exactly, the GC. They are the central figure, the individual, or maybe the firm that's responsible for turning, well, a stack of detailed drawings of vision on paper into something real, tangible, physical.
Wow.
It's a huge role. Immense coordination, practical wisdom, logistical genius, really. It's where design truly meets execution.
So today we're doing a deep dive into this fascinating world of the general contractor, the GC. We'll trace their history, from these ancient master builders right up to today's, well, tech-savvy project managers. We'll break down their huge responsibilities, things you might not even think about, uncover the pretty considerable risks they take on, and really celebrate the incredible skill it takes to bring these complex projects to life. We've pulled together sources from, well, all over. Ancient architectural texts, modern construction management guides, even biographies of legendary engineers, and insights into the latest project planning systems.
Yeah, we'll be digging into some foundational stuff, crucial nuggets from guides like the PMBOK guide, the CMAA Construction Management Standards of Practice. We'll look at the impact of things like the BIM Handbook and even draw lessons from strategic thinking in books like The Goal or the autobiography of a pretty famous architect. It's going to be a really comprehensive look at a profession that, literally builds the world around us.
Okay, so our mission today then is to give you a shortcut, a way to truly understand the pivotal role of the GC. That individual or firm overseeing the creation of, well, pretty much every building, bridge, and piece of infrastructure you see. You'll gain a new appreciation, I think, for the intricate dance of a construction project and the vital figure who leads it all from start to finish.
Right. And by the end of this deep dive, you won't just grasp what a general contractor does, but maybe more importantly, why their role is so absolutely critical to every building project, big or small. You'll see how history and modern practice are woven together. It reveals a profession that demands, meticulous planning, but also being able to solve problems on the fly. It really is a celebration of logistical genius.
From master builder to modern maestro, the evolution of the general contractor. Okay, let's unpack this. Let's start right at the beginning. Before we even had the term general contractor, who is actually building the great structures of antiquity. Think about the massive projects of ancient Rome, the Pantheon, those huge army camps, or the medieval cathedrals that took centuries to build. Who had the vision, the technical skill, the sheer practical knowledge to guide something like that from an idea to, well, completion?
That's what's so fascinating. Historically, the roles of designer and builder, they were often combined in one person, the master builder.
Ah, the master builder.
Exactly. And it wasn't just a title. It really represented this deep, holistic understanding of every single aspect of a project, from the initial idea to the final stone laid. These were figures with immense authority, multidisciplinary expertise. You look at ancient texts like De Re Metallica, it gives incredibly detailed instructions for building complex things like furnaces and pumps. The level of detail suggests, single authority overseeing not just the design, but the actual hands-on technical work on site.
Right.
Or think about those Roman army camps. Highly standardized, incredibly complex structures. That influenced later buildings, like Diocletian's palace. That required someone with comprehensive oversight, someone who didn't just understand the architectural plan, but also the logistics materials, labor, the practical side of building fortifications in all sorts of terrain.
So it was like a visionary who was also really hands-on, almost like a Frank Lloyd Wright, maybe. I remember reading in his autobiography how he didn't just design, he harmonized artistry with practical living, even logging his own timber when he needed to, just to make sure his designs could actually be built. It's that blend, isn't it? Conceptual genius and gritty, on-the-ground practicality.
Exactly. Precisely.
Yeah.
The medieval architects, the Vieux-le-Duc, described them vividly. They weren't just draftsmen. They were skilled builders, tasked with these vast and complicated edifices. Their challenge was to give these structures forms that perfectly harmonize with them by the most simple means. That shows a deep grasp of both design and the practical side, construction methods, materials, labor limits. Alberti wrote about the practical necessity of setting capitals on columns for architraves, to rest on fundamental structural stuff that master builders just knew and directed. Even Vitruvius, way back, gave meticulous instructions for practical things like laying concrete floors with specific mixes and slopes, or even how to drench joints with oil dregs annually to prevent frost damage. These are details a master builder had to know and supervise every single day.
So they were deeply involved in the day-to-day execution.
Absolutely. The Cathedral Builders really illustrates this. It talks about the huge challenges, the centuries-long efforts. It even mentions the serious financial problems that could stop work for a year if funds or materials ran out, like what happened to Canterbury Cathedral back in 1184. This shows an early sort of holistic responsibility for the whole project lifecycle, not just the building itself, but financing, resources, long-term viability. Responsibilities that honestly sound a lot like a modern general contractor's job, coordinating those huge multi-generational projects. That speaks to amazing organizational and technical skill, far beyond just artistry.
Okay, but somewhere along the line, that unified role, the master builder, it started to diverge, didn't it? It became less common, and we saw this clear split emerge between design and construction. What drove that shift? Was it just that projects got too big, too technically complex for one person? Or were there other things going on, maybe economic or societal pressures pushing for this specialization?
That's a really crucial point, and it leads us right to why the general contractor role emerged. As projects got exponentially more complex, needing highly specialized knowledge in structural engineering, mechanical systems, electrical networks, a division of labor wasn't just efficient, it became absolutely necessary.
Right, one person couldn't possibly know everything.
Exactly. It just became impossible for one individual to master all those diverse disciplines. The architect, for example, they might design the structure, the HVAC, the pipes, the plumbing, but their drawings, as the BIM handbook points out, often need extensive coordination between all these different systems. Yeah. You might have a clash on paper that isn't obvious right away. And, with increased liability concerns, an architect might deliberately include fewer details or add language saying they're not responsible for exact dimensions.
Ah, okay. That creates a gap.
A significant gap, a kind of gray area between the design intent on those 2D drawings and the intricate 3D reality of actually building it on site.
So the GC steps into that gap. They become the main manager of the means and methods, the subcontractors, basically the crucial bridge between the drawings and the physical reality. They're not just reading the blueprint, they're interpreting it, anticipating problems, filling in those gaps, making sure all the specialized pieces fit together, literally. So it's a shift from being a single artisan to orchestrating many different skills.
Precisely. The general contractor evolves specifically to bridge that gap. They become the single point of accountability for the whole construction process, translating designs into structure, meticulously managing this increasingly complex web of specialized trades and subcontractors. The BIM handbook talks about subcontractors doing all sorts of specialized tasks, fabricating plumbing fixtures, producing precise drywall panels, complex pipe sections. The GC's job is to coordinate all of that, make sure things arrive on site at the right time, get installed correctly, fit together seamlessly. This evolution wasn't just about efficiency. It was sheer necessity. The scope, scale, technical demands just outgrew any single master builder. They essentially became the ultimate project integrator, responsible for delivering the physical structure safely, on time, and within budget, a role quite distinct from the creative designer. 2. The GC's core responsibilities. The daily symphony of building.
Okay, so once the design is set, all those specialized drawings are ready, the GC's work really kicks into high gear. Long before the first shovel hits the dirt, right? It's not just showing up with a hammer. It sounds like there's a huge amount of strategic planning in that pre-construction phase.
Oh, absolutely. Far from it. The pre-construction stage is critical. It's the bedrock for the whole project's success or failure. Construction Management Jumpstart calls it job startup and really emphasizes it's all about project planning. It can set the stage for success or failure.
Yeah.
In this phase, the construction manager, and often that role is integrated with or done by the GC, works incredibly closely with the owner, sometimes influencing the project before it's even fully designed.
Really? How so?
Well, their responsibilities, according to the CMAA Construction Management Standards of Practice, include helping the owner develop a management plan, assisting in selecting the architect, which is huge. They also create a master schedule outlining the whole timeline, and even develop preliminary cost estimates during pre-design. This is where the strategy is laid out. Anticipating challenges, looking for opportunities, maybe suggesting value engineering alternative materials or methods to cut costs without sacrificing quality.
Okay, and this is where it gets really interesting and I imagine incredibly high stakes. the
Yes.
estimate. The financial backbone. This is where the GC puts a hard number on the whole vision, often before all the details are even finalized. That sounds like
Wow,
this very educated gamble.
it is absolutely a high-stakes calculation. The estimate, as construction management jumpstart defines it, is a summary based on the best information available of probable quantities and costs of materials, labor, equipment, and subcontracts to complete a project, including taxes, overhead, and profit. This number becomes the bid price, and if it's accepted, that's the contract. The crucial thing is, any errors or omissions in that estimate, the consequences are entirely borne by the contractor.
Wow. All on them.
All on them. It's immense financial risk, especially because GCs often work on really thin profit margins, maybe 2 to 5% on multi-million-dollar projects. Imagine bidding on a complex hospital wing. A seemingly small miscalculation underestimating the cost of specialized medical gas piping or misjudging labor for intricate cleanroom setups could wipe out the entire profit. It could even plunge the company into serious debt. It happens. Many firms have faced bankruptcy over one big project where the estimate went wrong. Estimating requires this incredible mix of precision, foresight, deep understanding of markets, supply chains. It's intense.
So that initial bid isn't just a number. It's a meticulously calculated prediction, almost an art form. And any misstep can cost them dearly. It kind of reminds me of that bit in the Bookhouse where the character Jim is puzzled by the high moral tone around not bargaining. It highlights those intense financial pressures, the negotiations involved. It's a world where every penny counts, isn't it? Accurate costs are crucial for everyone involved.
Couldn't agree more. And pre-construction also involves setting up the contracts, allocating risk. The CM or GC might recommend specific scheduling clauses, time extension rules for contracts with designers and other contractors. Critical decisions about how float that extra time and activity might have gets determined and managed. Should float be relative to the schedule or the contract date? How do you handle early completion schedules? These are all key considerations laid out in the CMAA standards. This detailed contractual groundwork is vital, not just to head off disputes later, but to ensure everyone understands the risks from the start. Think about the traditional design bid-build model. The GC comes in after the design's done. They take responsibility for building that design, including any errors they find in it.
So they inherit potential problems.
Exactly. That risk is core to their business model, puts huge pressure back on that initial estimate.
Okay, so once that contract is awarded, they get the notice to proceed. The planning shifts gear then, right? From strategy to tactics to execution. How does the GC keep everything moving forward like a well-oiled machine? How do they manage dozens of trades, thousands of tasks, countless deliveries, all happening at the right time, in the right order, without it just descending into chaos?
That's the million-dollar question, isn't it? How do you coordinate all that complexity? The answer is sophisticated scheduling. That's the GC's blueprint for action. They develop a master schedule that gives the big picture timeline to the owner. Then more detailed milestone schedules, especially during design, highlighting key events like completing 30%, 60%, 90% drawings, constructability reviews. For bigger, more complex jobs, they rely heavily on the critical path method or CPM networks. As the CMA standards outline, this isn't just a simple timeline. It's a dynamic model showing how everything connects.
Critical path. Okay, that sounds, well, critical. What does it actually mean for the GC? How do they use it to manage the project flow, especially when delays inevitably pop up?
The critical path identifies those specific activities where, if they're delayed by even a day, the entire project completion date gets pushed back.
Ah, the bottlenecks.
Exactly, the absolute bottlenecks. These tasks dictate the whole timeline and demand intense focus. Then there's float, or total flow. That's the amount of time a non-critical activity can be delayed without delaying the overall project. Managing this float is a real skill for a GC. It's often seen as a shared commodity that needs careful administration. Construction Management, the book, explains how using float on one task can impact later ones. Imagine pouring the concrete slab for the first floor. That's usually critical path. If it's delayed, the steel erection for that floor, which depends on it, gets delayed too, and so on.
Right, a domino effect.
Precisely. Now think about, say, painting the ground floor interior once the structure's up. If the painters are delayed a day or two, that task might have float. It might not impact the final project completion as long as they catch up before the final inspections. A good GC skill lies in identifying those critical paths, strategically using float to absorb minor bumps without derailing everything, and anticipating where delays might happen. They're constantly looking at the whole network of tasks and how they relate.
So they're not just looking at individual tasks in isolation, but the entire flow, all the interdependencies. This sounds remarkably like those concepts from the goal statistical fluctuations and dependent events causing problems in manufacturing. Managing those bottlenecks, those critical dependencies, seems absolutely central here. Like figuring out how to speed up Herbie, the slowest kid on the hike, so the whole group gets there together.
Absolutely. The parallels are incredibly insightful. Just like Herbie dictates the whole group's speed and the goal, a bottleneck on a construction site, maybe a specialized sub, a delayed material, a critical inspection, can dictate the whole project timeline. The GC is constantly identifying and easing those Herbies to keep things flowing optimally. And to do this, modern GCs use increasingly advanced tools. One big one is 4D BIM. It dynamically links the CPM schedule activities to the 3D objects in the building information model.
4D, so time is the fourth dimension.
Exactly. It gives you this graphically rich and animated representation of the planned construction sequence set against time. It lets you run powerful what-if scenarios, explore different scheduling options, spot potential clashes or logistical nightmares before they happen on site. As the BIM handbook details, this can save millions in rework, prevent huge delays.
That sounds incredibly useful.
It is. They also adopt lean practices, like the last planner system. This focuses on making reliable promises and proactively finding and removing constraints before work is scheduled. Constraints could be anything waiting on design info, prerequisite work not done, materials not available. This involves things like look-ahead schedules and daily huddles. The Practitioner's Guide to Essential Lean Research explains that reliable promising means assessing capability and capacity honestly. It's okay to say no if you can't commit. These daily or weekly meetings get everyone together sharing what commitments they've met, what help they need. This constant communication, this forward-looking problem solving, it's all about ensuring the right tasks sound in the right sequence and rate, making the workflow predictable, efficient, like smoothing out those statistical fluctuations on a production line.
Okay, so from these super detailed schedules and coordination plans, we finally get to the actual building part. What's the GC's role in the real nitty-gritty? Putting materials together, making sure every beam, every window, every pipe goes in not just a spec, but correctly, safely, efficiently.
Right. The GC is directly responsible for the means and methods of construction. And this isn't just high-level watching. It's hands-on, granular supervision and expertise across a huge range of trades. They oversee installing everything, from basic structures like wood-light framing, which fundamentals of residential construction calls the most flexible system, to complex masonry, precise concrete work, intricate steel trusses, as shown in fundamentals of building construction. They have to ensure tiny details are right. Proper joist spacing 12, 16, 24 inches on center, depending on the load. Correct nailing schedules for framing. Proper insulation, baffling to stop wind washout. Meticulous sealant application around windows and doors to keep moisture out. All those details from books like Building Construction Illustrated and Builder's Guide. It requires this encyclopedic, practical knowledge of how countless different pieces interact, perform, and meet codes.
That sounds like an incredible depth of knowledge across so many disciplines. Almost like being a master of all trades, not just one. They need to know about wood properties, sapwood versus heartwood, how moisture affects it, like from understanding wood, and complex structural stuff, cantilevering, shear walls, footing stresses, like in the Kidder-Parker handbook. It's not just knowing what to do, but why it works, how to fix it when it doesn't, and predicting problems before they happen.
You've absolutely nailed a core part of the job. They have to understand material nuances. For example, that knots significantly weaken wood, or how changing moisture content causes warping and checking, which compromises structure or looks bad. Understanding wood goes deep into that. And this directly feeds into quality control, ensuring all work is being performed in accordance with the contract specifications and best practices. This means verifying daily inspections and tests, maintaining thorough, accurate records through daily work tickets, project management, and construction, stresses these should be signed daily by both parties to avoid disputes later, and meticulously tracking every single change in the work, as per CMAA standards. They are the ultimate guardians of the specs and the build quality, constantly checking, documenting, adjusting.
So not just supervising, but constantly checking, documenting, adjusting, almost like an on-site quality assurance department. And what about the big push for sustainable construction? That must add another complex layer, right? Integrating green materials, technologies, meeting standards like LEI.
It absolutely does. Modern GCs have to not just understand, but skillfully integrate green building materials and tech, ensuring they meet tough standards like LEED. The Sustainable Construction Source gives a really compelling example. The Bank of America Tower in New York achieved an impressive LEED Platinum rating for its sustainable features. But remarkably, its initial energy performance was, Well, unremarkable. It actually used more energy than the 80-year-old Empire State Building early on.
Really? How?
Well, partly due to factors like tenant operations, which weren't fully controlled by the project team. Think firms with huge numbers of computers, servers running 24/7. This example really highlights the GC's challenge. They have to deliver complex outcomes that meet both the design specs and broader performance goals, like sustainability, which often requires a much more integrated long-term view of the building's whole life cycle. It's about delivering not just a structure, but a performing structure. 3. Navigating the minefield, risks and relationships.
It really sounds like the GC is on the hook for an incredible amount. Responsibilities ranging from the tiniest detail, like sealant, to the huge scale of the entire project's financial health. What kind of risks are we really talking about here? Beyond the complex dance of scheduling and managing trades, what are the financial and legal tightropes they walk every single day?
The financial risk is immense, and it starts right back with that initial bid we talked about. Beyond those razor-thin margins and the risk from estimate errors, which, as construction management jumpstart clearly states, are borne by the contractor, they're responsible for multi-million-dollar outcomes with potentially huge downside. They navigate incredibly complex contracts. Construction Management Jumpstart details how things like how many contracts the owner signs, the specific roles of each party owner, designer, contractor, and crucially, who guarantees the plans are sufficient, all fundamentally shape the GC's risk.
Right, the contract structure matters hugely.
Hugely. In traditional design bid build, the contractor comes in after design, takes responsibility for building that design, including any errors found within it. They inherit that risk. But in more collaborative models like design build or construction management at risk, the GC is involved much earlier, sometimes during design. They can offer critical input on buildability, help share or mitigate design risks more effectively. That choice of contract model really shifts who carries which burden.
That's a critical difference. And when things inevitably don't go exactly to plan, which, let's face it, is almost always the case in construction, how are unforeseen conditions or design changes handled? It seems like every project must face changes, adding another layer of financial and logistical stress.
It's a universal truth. It is extremely rare to find a project that is built exactly as it was originally designed without any changes, as Construction Management Jumpstart puts it. Errors, omissions, owner, needs, changing. They always happen. When they do, the contractor is usually entitled to extra money, sometimes more time, through change orders. The GC manages this process, whether it's adding or deleting work, but change orders can easily become a major source of disputes, claims, added costs if not handled meticulously.
I can imagine.
And sometimes it gets even trickier. An owner might issue a construction change directive without prior agreement on cost or time, as mentioned in project management in construction. This puts even more pressure on the GC to manage the financial fallout and potential claims later. It links back to the PMBOK Guide's point about managing unanticipated or unwanted consequences. The GC's ability to track and document every change meticulously, daily tickets, photos, detailed emails, is absolutely critical for getting paid fairly and avoiding costly legal fights. It's an art of careful negotiation and rigorous paperwork.
Okay, beyond the complex financial and logistical balancing act, there's the huge concern of safety. How do GCs make sure everyone goes home safe at the end of the day? Especially on these busy sites with heavy machines, heights, countless moving parts, hazards are everywhere.
Safety is absolutely non-negotiable. It's a primary, unwavering responsibility for the GC, not just compliance, not a box-ticking exercise. It's fundamental ethical, woven into everything they do. They appoint a dedicated safety rep, conduct daily inspections against set criteria, and perform job hazard analyses, JHAs, for all critical or high-hazard activities. That's detailed in the CMAA standards.
JHAs? What are those exactly?
It's not just a checklist, it's a systematic review for specific dangerous tasks, lifting a huge steel beam, working in a confined space, digging a deep trench. You break the task down into steps, identify every potential hazard for each step, beam swinging, trench collapse, gas leaks, whatever it might be, and then you outline concrete safety measures to mitigate those risks before the work starts. These JHAs are then thoroughly discussed in safety meetings with subs. GCs also participate in job site safety committees, reviewing issues monthly, promoting a safety culture, and the consequences for failing are severe. If a contractor doesn't fix an unsafe condition, the owner can issue a stop work order. No extra time, no extra money. That really highlights the GC's direct accountability. While an unsafe condition exists, lives are literally at risk.
Wow, okay. And construction projects involve so many different people, organizations, owners, architects, engineers, tons of subcontractors, suppliers, regulators, even the local community. How does the GC manage all these dynamic, sometimes conflicting relationships? Especially when, as the PMBOK guide mentions, some stakeholders might not even support the project.
Effective stakeholder management needs exceptional people skills, leadership skills, arguably just as important as the technical project management side. The GC has to foster, as the PMBOK guide puts it, a transparent working environment, open communication channels, and opportunities for stakeholders to raise concerns without penalty or fear of retribution. That means actively listening, engaging with everyone from the owner down to the neighbors affected by noise. And stakeholder influence, power, interests can change dramatically during a project. Constant vigilance and adaptability are key. Maybe a local group was neutral initially, but then gets very vocal if construction blocks their commute. The GC has to navigate that evolving landscape, address concerns proactively, build consensus to keep things moving, and avoid costly delays or PR disasters.
So it really boils down to building trust and being proactive. Addressing concerns before they blow up requires a lot of emotional intelligence, foresight, and, well, consistent ethical behavior.
Absolutely. Trustworthiness is core. The GC, or stewards, as the PMBOK guide calls them, must accurately represent their authority, proactively identify conflicts of interest that could undermine trust and confidence or lead to unethical or illegal behavior. And this applies to their whole team, all their subs. When breakdowns inevitably happen, and they will, the GC needs a solid system to react and learn. Something like DCAP, detect, correct, analyze, prevent. Detect the issue close to the source. Take immediate corrective action to get things running again. Analyze the breakdown to find the root cause. Then implement countermeasures to prevent it from happening again. Say, a new plumbing fitting leaks detect. Crew tightens or replaces it immediately. Correct. But then the GC investigates. Faulty part, bad installation, lack of training. Analyze. Based on that, maybe they switch suppliers or retrain the crew. Prevent. It's a continuous improvement loop. Reflects the Plan-Do-Check Act cycle, as explained in the Practitioner's Guide to Essential Lean Research. This adaptability, this resilience, the ability of a system to bounce or spring back into shape, as Thinking in Systems describes it, is crucial. Construction is inherently variable, unpredictable. You need a robust system that learns and adjusts constantly. 4. The logistical genius. Stories from the field.
This whole deep dive really paints a picture of incredible practical wisdom, problem-solving skills, almost a kind of logistical genius that's hard to grasp just from reading plans. Can you share some stories from the field that really illustrate this? Moments where a GC or someone like them had to pull off something amazing through sheer ingenuity.
Oh, absolutely. One really fascinating example is Isambard Kingdom Brunel, legendary 19th century engineer, almost a master builder in his own right, designing and overseeing huge projects. The Great Western Railway, that revolutionary bridge over the Tamar River. The biography, Isambard Kingdom Brunel, details how, while he was this incredible visionary, he sometimes overestimated the ability of his fellows and of the technical equipment of his day, or even hamstrung the unfortunate builders with his super ambitious requirements. For the Great Western Railway, his insistence on broad gauge track and strict limits on piston speed forced builders to create locomotives with massive 10-foot driving wheels.
10 feet, wow!
Yeah, and even mount boilers on separate carriages to meet his weight rules. It just shows this huge tension between ambitious design and the practical reality of building it, and the builder's role in making it work, despite limitations that might seem impossible. His experiences at Chepstow, and then the even bigger challenge of bridging the Tamar River, 1,100 feet wide, 70 feet deep. He had to keep discarding designs, timber, massive single spans because they were too difficult or expensive. He finally settled on 2 main 465-foot spans with just one deep-water pier that required immense on-the-ground problem-solving, adaptation. Brunel was essentially acting as his own GC, facing engineering challenges nobody had faced before, constantly innovating, adapting designs to the available tech, materials, workforce. His genius was understanding not just what to build, but how to make it physically possible, and sometimes inventing the way to build it.
That's incredible. So even with a visionary like Brunel, the practical execution needed immense skill, adaptation, pushing the boundaries of what was even possible then, really highlights that critical gap between the drawing board and the dirty, difficult, often innovative work of building, and the person who has to bridge it.
Precisely. And another story, maybe simpler but just as profound, comes from The Goal, that hike with the Boy Scouts. It brilliantly illustrates bottlenecks and throughput. Remember Herbie, the slowest boy? He determines the speed of the whole group. When he leads, everyone slows down. Because, as the leader says, the idea is to get there together. The lesson is, to speed up the whole system, you have to figure out a way to let Herbie go faster. Optimize around the constraint, the bottleneck.
Right, lighten his load or put him at the front.
Exactly. Maybe offload some of his heavy pack to faster scouts, or move him to the front so his pace, once optimized, dictates the group's speed. It's a fantastic analogy for managing construction flow, identifying that one resource or activity holding everything else up.
That is a perfect analogy for coordinating dozens of trades, thousands of tasks. The GC is constantly spotting and easing those Herbies on site, whether it's a delayed delivery, a concrete pour taking too long, a crew waiting for another trade, a critical inspection holding things up. Their job is keep that whole procession moving forward optimally, constantly looking for ways to lighten Herbie's pack, get him moving faster, maximize the overall project throughput.
You've absolutely got it. And this connects really well to that idea of track one wisdom from shop class as soulcraft. Remember the mechanic pointing out that subtle but crucial detail in installing a chain, something only years of hands-on experience teaches you. Shows how practical, on-the-ground experience refines understanding in ways theory just can't. It's that kind of deep, intuitive, foresightful knowledge that lets a GC spot potential Herbies or subtle problems before they become big, expensive ones. Louis Sullivan, in his autobiography, talked about studying architectural history not just as fixed points, but as continuous outpouring from the infinite fertility of man's imagination evoked by his changing needs. That reflects the lifelong learning, the evolving practical wisdom needed by a true master craftsman or a general contractor, constantly adapting to new materials, tech, client needs, while building on centuries of experience. It's a truly dynamic field.
Wow. What an incredible journey into this really multifaceted world of the general contractor. We've seen how they're this blend of historian, visionary, strategist, and, well, hands-on problem solver, navigating complex histories, managing huge financial risks, orchestrating intricate schedules with amazing precision, ensuring the safety and quality of every single nail, beam, and brick. It's so much more than just building. It's this art of coordination and leadership that literally shapes the world we live in.
Ultimately, yeah, the general contractor is that pivotal figure, taking abstract ideas, detailed drawings, and through immense skill, coordination, practical wisdom, turning them into the physical realities we use every day. From those ancient master builders raising cathedrals to today's tech-savvy BIM integrators leading skyscraper projects, their role has always been about making the impossible possible. They're the nexus point where innovative design meets meticulous execution, constantly balancing creative vision with practical limits, continually pushing the boundaries of what can be built safely and efficiently.
It really is a celebration of logistical genius, turning a vision on paper into a place where we live, work, and thrive. You'll definitely never look at a building or a bridge the same way again, knowing the incredible depth of skill and responsibility that goes into it.
So maybe here's a final thought for you to mull over, something provocative. With all the rapid advancements, we're seeing digital tools like BIM, AI, and project management, sophisticated off-site prefabrication, and with projects getting more complex, focusing on sustainability, resilience. What kind of new master builder role is maybe emerging for the general contractor? How will this ongoing evolution reshape their core responsibilities? What new skills will they need? Data analytics, digital twins, supply chain optimization, and what unique challenges will they face in continuing to turn dreams into physical reality in the years ahead? It's definitely a field of continuous improvement, continuous adaptation. The demands on this master conductor are only going to grow.